Yes. 10 years ago, I was having a chat with a friend of mine. He's a very bright and smart mathematician, PhD, actually one of the smartest I know. That was 10 years ago, and we were talking about AI, what are the changes going to be, what will the future look like. And he said that regarding self-driving cars, there will be so many difficulties that we need to overcome before we get to self-driving cars. So we will only see them like years, long time ahead. It will take a lot of time before we have self-driving cars. But today, the situation is anyhow that if you look at the front edge of self-driving cars, they are actually doing a lot what we couldn't even imagine back then. They are changing lanes. They are taking off on new roads. When in city traffic, they adjust to bicyclists and so on. You have also maybe seen the Boston Dynamics and the robots that they create. For construction working, they make them dance. And those are things, just looking back a couple of years, that we were not able to imagine. So really a big change regarding what's going on in AI, as we all know, on the front edge of AI. But on the other side, if we think of ourselves a few years back, where did we expect the big changes to come with AI? We expected them to change blue-collar jobs. Self-driving would replace drivers, and so on. But what is actually happening and what we see now is that with ChatGPT, we all see that the change is coming for white-collar jobs as well as blue-collar, and maybe even faster with white-collar jobs. And that is also something that makes it really interesting for us. And I think that's the second reason why we are interested in the topic today. It's not only because AI is that so much has been happening with AI. It is also that it starts to impact our work, how we do work, and we see that there is a big change coming. And what I want to speak about today is first, what is AI? What's included in AI? And how can you structure it? What are the different types of AI that is available? And then share a few cases on what we have done with AI, just to make it a bit concrete. How can AI and what is found in the AI toolbox support what I'm doing in my daily work? Artificial intelligence. What is it? It's two parts. It's systems that perform tasks. That's part one. So there is a system that actually do a task. And what kind of task? That's the second part. It is a system that performs tasks that requires human intelligence. So what's human intelligence? Some kind of a decision making, some kind of action that requires that you think. And that's a broad definition from what artificial intelligence is. Systems that perform tasks that requires human intelligence. And this is actually a ChatGPT definition. The structure of this presentation is also based on ChatGPT. So that's how it come in and support you in your work. You can have like this helper there giving aid and support. Well, having this kind of broad definition, having these tools, thinking about self-driving, thinking about different technologies that come, how can we structure it and build it and put it into different buckets, artificial intelligence, what's what? And a way to look at artificial intelligence is to divide it into boxes. Well, boxes are difficult in one sense, because they kind of, with a box, you tie something into that box. And a lot of these technologies here, what you see, are not, they are related to each other, and depending on the use case, you can have a mix of them. But anyhow, on the upper row there, you have machine perception. What's that? That's a lot about gathering data automatically in an amount that we have never seen before. We have natural language processing. Well, that's about collecting. First, it's about collecting data in a much more efficient way than we have never done before. Computer vision, getting the computer to understand what's in a picture and make use of that. And then speech technology, from text or from speech for the computer and for the system to take that speech in and make something usable out of it. So systems that perform tasks that require human intelligence. These are very close also from the front user side. Natural language processing, computer vision, and speech technology. But below these, there needs to be methods and way of working to use the data, use the data that has been collected with different methods. And these are then decision support systems, it's machine learning and optimization. And I'd like here now to just go through a couple of cases regarding these three, so and to try to bring it to concrete in what way can AI be used in different organizations. So the first is decision support systems. What is that? Well, it always takes a lot of energy, and it's difficult to take a decision. There's a story about Obama that when each morning he wanted to go out with as much energy as possible. So he didn't have to choose what to wear that day. So he had his whole wardrobe was filled with the same kind of suits, with the same color, same tie, same shirt. No decision to be made, always looking good. And that's kind of the core of the problem. Decision making takes energy and is a complex thing. And decision support systems are systems that support better decision making through data, analytical tools, and models. So it's a pretty broad area, but the thing here is that in this case, you can use different methodologies to make those to support the decision making, but at the end of the day, it's a human that makes that decision. But it can help in understanding and modeling complex processes, gain a better understanding of the process. So if you are a manufacturer and you have raw material costs that come into and have a big impact on the margin of what you sell, then a decision support system can help you in hedging and managing, for example, that risk from the price risk in the raw material, and makes it. But at the end of the day, it's a human that will make a decision how much to hedge, how much to buy in. A case we made here was for a power production and retailer, and the question for them was, should we buy from the micro producer or the market, and at what price regarding solar power? They had an opportunity to build a solar power production and possibly combine that with some batteries. Well, battery energy isn't cheap, so what's the value of adding that battery setup into the whole should you include it or exclude it? Well, the market is in electricity is interesting in that sense that if you make, for a power producer, you make a forecast of how much you're going to produce in 1 day's time. And then you get a price, the spot price, based on that, based on your forecast. But if the actual production differs from your forecast, so if you say forecast that you will produce 1 megawatt hour tomorrow at noon, but you only produce 0.3, then you anyhow need to come up with that difference, the 0.7, and buy it not from the spot market, but then you need to buy it from the balance market. And if the spot market is volatile and can range from 0 to 500 euros per hour for 1 megawatt, the balance market is 10 times as volatile. So you want to know what's the value of a good forecast. And in that way, we built different models, and were able to cap the min risk, the max risk from the forecasting model. What would a simple model make of a forecast, and put an actual price on the risk of that forecast. So that's an example of a decision support system. Then machine learning. Well, what is machine learning? It's solving a pretty specific task by learning from data. And as humans, we are very bad generally at understanding and forecasting based on data. As long as 85% of drivers think they are above average, we will be bad at judging data. And so machine learning, taking data, using it to forecast, predict, or adjust for behavioral biases that we have inherent in ourselves. So can be used in quality control, for example, credit scoring, reading in bank statements, and taking in social media in order to classify a client and really put a number on the risk of a client based on the data that comes in. A case that we made regarding machine learning was for Dermosil, and they are a retailer of skincare products, and hair care overall products that you have in your bathroom. And an online retailer So, have been around for 20 years with a long and large client database. And here, they wanted to understand their customers better. So from this vast data that they had on their customers, their buying habits, what kind of products they bought, how often they bought, did they buy only with a small orders, or were they buying more infrequent but with large orders? Kind of all that data has information in it and can help the marketing team to target really their the clients with the different products. So here we first we wanted to segmentate the clients, and the big important thing is that we had first built the BI models for the reporting, so we knew the business very well from the beginning, so it was easy and a fast start for us. So the first thing we did was to build a churn rate model. Well, the churn risk is the risk of a client falling off the next year. So how well can you say that the client will not make a purchase during the next 12 months based on the behavior of the historical behavior? And when you can identify those clients, then you can also use that information to target the marketing towards them with specific products, with specific packages that makes it interesting. So the client did get a client segmentation based on the churn rate, so a model for the churn rate where we forecasted the risk of every client not buying the next 12 months. The segments were based on what kind of churn risk they had, but also based on a lot of other data regarding the client. And this was all integrated into Power BI so that the client really could use these client segments to further identify, to test different own hypotheses in that environment. The third I would like to speak about is planning and scheduling. So optimization was the third box there. And here planning and scheduling is about creating optimal plans and schedules based on data. And when new information comes in, when we create plans manually, it often takes a lot of time before we can adjust to new data. So if we have a manufacturer again, and you have the situation that you get new cell orders in, and you have production lines, and one production line goes down, then you want to reschedule depending on what's waiting there in the order book. And you need to do it fast. And with planning, scheduling, and utilizing optimization, this can be done. So what we did here was with Wärtsilä, and they build part of their business is to build power plants, and each power plant has a different number of power generating units in them. Each power plant needs to generate some electricity all the time, but it also needs to generate enough electricity according to what has been agreed with the buyer of the power plant. And if you have 10 power generating units, then the question is that these need to be maintained, and you have maybe one maintenance when one unit has been run for 1,000 hours, you have a bigger one coming after 2,000 hours, and an even bigger after 4,000 hours. So you get a situation where you have some units are down at some point in the time. And these maintenance need to be aligned with the power production required. And then again, if you have an event that something goes down unexpectedly, you have a machine that goes down, then you are in a situation that you need to move production from one unit to the next unit. So there were two questions there. One, you had an operator running the production site. He asked that which unit should I start and in which order at this moment. That was one problem. But the second problem was, what should the maintenance schedule look like in an optimal case? And the value, if we were able to solve this, is, well, power availability is ensured to end clients. Equipment depreciation is minimized. If you do the maintenances on the right moments, then of course your engines will last a lot longer. And then third, there were a lot of people skills involved in just making those decisions on which to start, which unit to start in which order, and then secondly, to plan those maintenance schemes. So here it was a kind of we built this optimization problem where there were two steps. First, a starting order priority, solving the problem of which unit to start in which order. But then also it turns out that depending on when you start a unit, then that has an impact on the maintenance schedule. And the maintenance schedule in itself could be also better arranged for the purpose. But then when you had rearranged the maintenance schedule, again, you needed to rethink the starting order and make it a kind of a loop that searched the optimal solution for these two problems together. So these are three examples of AI and how it can be used in different business environments. Well, if we then think in our organization, where I work, how can we start this process of making what we do to something concrete that can be used and possibly solved with AI? I think it's a really important to try to find those good use cases. And there are, in each business, there are so many use cases that can be solved. And the first thing, and that's on the top there, is to collect these business needs. So thinking broad, what are the possibilities that can, and where are the cases where we could possibly apply AI to either add value, become more efficient, become smoother, make something easier, or make something faster. And looking also hindsight on the business, hindsight on the technologies available. And from this broad set of ideas of collected business needs, to identify use cases where AI can be used and where there are technologies available, and where it also, point 3 there, where business value is pinpointed. Then, fourth, map out the data availability. Do we have the data, and what do we need of data to come forward? Define a scope and pilot a project. And this is a part, and this whole part is, of course, where also we can be part of supporting you in solving this and make be a help for the actually getting AI into the right business cases where it has the most use in the business. Thank you.
Thank you, Daniel. Now we have time for a couple of questions, if anyone has something to ask about Daniel. It seems to be there. Wait for the mic.
Okay, hello. I do have a question. Thank you for speaking today. I think it's very interesting to see what Atea is doing on the AI space. And I wanted to ask you if you had any chance yet to work on generative AI, for instance, by creating some conversational chatbots or helping with knowledge management and so on?
Yeah, if I did understand the question, you asked if we have worked with, for example, chatbots and somehow the sound is not. I could maybe go down here in front of the speaker and can you repeat the question? Sorry.
I'm asking more about generative AI. So you talked a lot about AI in general, but if Atea had the chance to work integrating generative AI into business processes to enable, chatbots, conversational chatbot with employees or customers, and those type of projects.
Yes. Yeah, actually, the Atea is, as we all know, not only a Finnish organization, but it's really a Nordic organization with a strong foothold in both Sweden, Norway, Denmark, and all the other Nordic countries. And actually in Stockholm, Atea put together a really interesting concept regarding pulling in people from different kind of the business and really doing this process that we painted out in the beginning, and so Atea has done and brought also several of those cases forward with generative AI.
Any other questions?
Thank you for an interesting presentation. What's your opinion on how much complexity can we manage with those systems that we are applying currently? Because as you say, the kind of many of those examples, they are quite complicated, but still there's so much more complication in the world. So what would you say, how many decision factors or attributes can we get into one of those solutions at maximum?
Yeah, I think this is a really interesting topic also, because if you just look at for example, ChatGPT and the capabilities of ChatGPT, and it was launched about a year ago, if I don't recall falsely. So then there was a lot of issues. You could play around like with and have fun and joke with ChatGPT on that your tools were not, or you could test like logical problems. A, B, and C goes to an island. A kills B. C is not the murderer. Who's the murderer? And it was like not able to solve that problem. Today, that's not the case. So today, actually, pretty difficult, but kind of mathematical problems on maybe not university level, but a bit below that can be solved with ChatGPT, also with this kind of logical components. So I think, and that's a thing that has been changing only in 1 year. So I think what we will have in just 2 or 3 or 4 years will be so actually different from what we have today, because these technologies will be so much more used. So on kind of the complexity, where is the level? I think that kind of where you see that will move forward in a fast pace.
Okay. There is one more question, then we have run out of time.
Yeah. Hi, thanks for the presentation. In your opinion, what are the key success factors for organizations taking their first steps within AI?
Yeah. I think there are like two very crucial, 3 crucial, but maybe but the first one is to be open-minded on the use cases where you can adapt, to really think through that where can AI be adapted into our processes, and have someone with them to support in also what kind of technologies can you apply to solve those problems. And then very important, of course, is to identify the cases where you actually have the business value, because otherwise it will just be something that you throw money on and you will continue as you have always done. And then very important also is AI doesn't go into production overnight. If there's a complicated process beneath, it will take time to fix the issues, to build the models, test it, and test the solutions. So to not leave the game too early, I think can be actually something worth keeping in mind also, but when identifying those business cases.
Okay, thank you, Daniel Djupsjöbacka.
Thank you.
Now we change applause. Thank you.